I'm going to talk about backward propagation in neural networks. So if you see this image, if you might, are you able to see or not? But what I'm trying to say here, so this is the input layer, hidden layer, and output layer. So when the normal flow is forward propagation, but we are going to backward sides, like for example, right? Uh, For example, we are learning cooking, right? So in cooking, you cook meal in forward process, and then test and the loss function, right? Test whatever you expect, there is not result. You get feedback each ingredient and backward so you get feedback and then improve again, then test again, and adjust recipe the next time. That is a way to adjust. So this is a very simple example, and I have given the example. It's very useful. Simple neural network. I'm going to, you know, I have put here forward propagation, backward propagation, forward, backward, everything's right. So think like error. Error flow backward, like water flowing downhill. Each layer get the share of this blame. Error, output layer, hidden layers, and input. Each step multiplied by contribution. Third step, forward, input, hidden, and calculate error. Then again we calculate error and then see, right? This is how input layer, output layers, and so on. So error, predict minus actual, gradients, errors, input. So this is how it can go. I'm going X, uh, Excel row I'm going to use. This is what I used before. So neural language is very simple. This is input layers and this is output layers, right? Now output, this is input. Now you are cooking here and this is the same output. So input, you do some process, it's happening here, right? And then it is, you expect something good thing, but it's not happened. Then again, we change the ingredient and check. So this is neural level, real world. Everyone contribute the forward process and give the team feedback. Loss, each person learned that the part of mistake. This is backward propagation. Everyone adjusts their weight with this weight updates. This is how it will. So if you see, I mean, this is example I gave, but you can go through this one. And this is measure, you know, this is the measure the error. So y minus y. So the predicted value minus actual value and the square and divide by 1 by n. So how far the prediction are from the actual value, square the difference handle to a negative value, take the average and get the errors. Why this square errors makes the all error positive. Penalize larger error is more easier to work with them mathematically. When to use regression problem. So this is for regression problem when the error is particularly bad. When you, so real world example, this is how I like, predicted price, actual price, some stocks or house, and then we find the errors. So large number of, because price difference is squared. So this is how you can calculate for the example. And optimizing neural networks, there is a define the weight and bias, hidden layers, output layers, and so on. So these the things. Here is things, right? You need to learn about sigmoid function, optimizing how the sigmoid function is working. I have run my code and all the explanation I have given you here, right? So you guys need to go through input, weight, sigmoid, output. Backward propagation is systematic way to updating weights and bias across all layer to minimize the loss function. This is the how which we get. This is input layer. This is the next layer. This is called hidden layer, then output layer, and the loss function is here. Based on that, we will update the previous value, and this is how it's make the idea, right? So the actual idea is making the guess forward, seeing the how wrong we are lost, working backward to fix mistakes. This is how which backward propagation, and this is how I did. And there is some mathematical function is behind the scene, input layer, hidden layer, output, training forward loss calculation, backward calculation. This is mathematical formula. So new equal to old learning rate in gradient. So these are the learning rates, right? Gradient learning rates. This is learning rate and then gradient. Weight, number of, decide how important each connection, bias is number of file. Just a final answer. How do we have to take what we have now? Old versus subtract the small adjustment. The code is here and easy to remember. The net neural gas prediction y. You can compare to the correct answer. If the wrong, the correct the mistakes, and the here mathematically function, which I lost function, update weights, right? And the simple Python code also I say a real world example, face recognition, self-driving car, chat GPT. Okay, how to remember things like training a child, guess, forward propagation, click mistake, loss function, correct mistake, backward pro, simple rules for weight, new weight, old weights, small step in gradient. Always subtract the gradient to reduce error, right? That's why it's always subtract. Yeah. Thank you for watching. Please like and subscribe my channel.